In this video, I will talk about agents which became ubiquitous in industry and in academy. To do so, I will walk through this white paper published by Google, which I recommend you guys to read more in details if you need to go deeper. So before going into details about concepts related to agents, let's see this general agent architecture in applications, for example, with a single agent. So an agent is composed of three components. The first one, which is the brain of the agent, is the model. And this can be any LLM that we see nowadays, from OpenAI, Google, Llama, DeepSeek, Mistral, and so on. We have the tools part, which are the tools to which the model has access to go to look for information from external resources. And we have the orchestration part, where the reasoning, planning, and actions take place. Don't worry guys if it's still not clear. We will see each of these concepts in details in the next few minutes. Let's start with talking about models. So as I already mentioned, they are the decision makers for agent processes. Models can be small or large and capable to follow instruction-based reasoning and logic frameworks like React, Chain of Thought, and Tree of Thoughts. We will see each of these frameworks in details. Also, models can be general purpose, multimodal, where they accept text or image, or fine-tuned, where you start with a general purpose model and you fine-tune it to become oriented towards a more specific domain. For best production results, a model should fit a desired end application and ideally trained on data signatures associated with tool that you plan to use. And talking about tools, this component makes agents able to interact with external data and services. To give you an example, a tool can give the ability to the agent to update a customer information in a database, or to fetch weather data, or to do a search in a search engine, and so on. This is a game changer, guys, because with this, agents can access and process real-world information, and this bridges the gap between agents' internal capabilities, or the LLM internal capabilities, and other data present in external resources. Now, concerning the third component of an agent, which is orchestration layer, it actually represents the process of the agent taking in information, reasoning about this information, and use this reasoning to decide the next action that should be taken. Let's look at a visual example that summarizes all this. So here again, we have our agent architecture. We have the first component, which is the model. We have a bunch of tools from which the model can choose to answer to question. And we have the orchestration layer. So let's look at this example. We have a user who wants to book a flight from Austin to Zurich. The input to the agent will be the user question. The model thinks about what to do. So here it says, I should search for flights. The model decides to use the flights tool that is provided here with the list of tools. The model decides to give the departure and the destination of the flight. This will be passed to the tool. And in the observation step, we have the tool output, which is, let's say, many options that the user should choose from. After that, the model decides that it should directly present this output to the user. So at this step, the model decides that it's satisfied with the tool output and it should present it to the user. But these steps, guys, can be repeated n times before the final answer is returned to the user. But in our case, as the model is satisfied with the answer returned by the tool, the final answer will be returned. That's it. This is amazing, guys, isn't it? And it's to be noted that here we are using the React framework, but we have other frameworks, as I told you in the beginning of this video, which are the Chain of Thought framework or COT for short. The framework enables reasoning capabilities through intermediate steps that can be defined in advance. Or we have the tree of thoughts framework, which is actually a generalization of the chain of thought framework. And we have the word tree in the framework name because in this framework, the model explores many thought chains as if it was using the chain of thought framework many times before giving an answer at the end. And if we go back to our agent architecture, guys, this is a game changer because it helps to avoid hallucination that we've been seeing from the emergence of LLMs. And this helps to avoid hallucination because the model doesn't rely only on its prior knowledge, but it uses external information instead, thanks to tools to provide a grounded answer to the user. And as examples of tools, we can mention those which enable agents to adjust smart home settings, update calendars, fetch information from database, and last but not least, send emails based on specific information. Now, as of the date of this video, we have 3 categories of tools. The first one is extensions, second one is functions, and the third one is data stores. We will see each of these categories. Let's talk about each of these categories. This is an example of an extension used as a tool. The big advantage of extension is that they teach the agent everything about the API. So we don't need to provide any prompt to the agent to show it when to use the API or how to use the API or which parameters are needed by the API, because all this is provided in the extension. As you see here, it includes information when the API can be used. It can contain examples when to call the API. For example, here it tells the agent to call this API when the user wants to search for flights. And it even gives information to the agent about args that should be passed to the API. Here are some examples of real extensions like flights, maps, or weather extension with their associated APIs. Now, if we compare extensions to functions, functions also do the same work as extensions, but not in the same way. As you notice here, neither the function nor the agent are related directly to the API because the API call is done in the client side. It's fine, guys, if you still don't see how function calls work. You will see it in this diagram sequence. So let's take the same example. Here we have the user query that will be passed directly to the agent. Based on the provided information, the model decides that the display cities function should be called because the user is looking cities for ski trip. This information is received in the client side and the API call is done at this level. So all information needed to do the API call, including the call format, the arguments needed by the API, and so on, should be managed at this level. And here is the main difference with the extensions, because in the extension, all this is done within the extension. But here we have advantages as well, because this part can be controlled in the client side, and we have more flexibility as well, because we can make these calls in any layer of the application and not necessarily within the agent layer. Also, if we have any security restrictions with the use of functions, we don't need to give any authentication information to the agent to call the API. Now let's talk about the third and last category of tools, which are data stores. So as you see here, we have data store instead of extensions or functions, and these data stores contain information extracted from external resources that could be fetched from websites, from structured data, or even from unstructured data like private documents. And this reminds us of retrieval augmented generation based applications, or RAG for short. So as a reminder, let's see this life cycle of a RAG-based application. So here we have the user query. This query will be converted to an embedding. The embedding will be used in a similarity search to look for the most relevant documents in the vector store to answer to the user query. Once this is done, the relevant documents are returned and they will be given with the user query to the agent to provide an answer. And don't hesitate, guys, to go to watch my previous videos to have more details about each of these concepts. This is it, guys, for today. In the next video, I will present a real use case where we put all these concepts in practice. Thanks for watching. I hope you liked the video. Don't forget to subscribe to the channel to have more videos like this one. And please let me know in the comments if you have any questions, and see you next time.